Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Optical storage technologies represent one of the foundational methods of reading and writing data using light. These devices rely on a laser mechanism to interact with specially coated disks. When the laser beam strikes the surface of the disk, it either reflects back cleanly or gets scattered based on the presence of microscopic pits and lands, encoding binary data. Optical drives have long been used for various tasks in computing, such as playing audio and video media, backing up files, and installing software from physical media. On the CompTIA A+ exam, candidates are expected to understand the types of optical drives, the capacities of their associated media, the read and write speeds, and the different formatting standards used across various formats. Compact discs, commonly known as CDs, are one of the earliest forms of optical media widely used in computing and multimedia applications. A standard CD can hold up to 700 megabytes of data, which was once more than sufficient for software installation and audio storage. There are several variants of CD technology that you need to know for the exam. CD-ROM stands for Compact Disc Read-Only Memory and is pre-written by the manufacturer with data that cannot be changed. CDR refers to Compact Disc Recordable, which allows users to write data a single time. CDRW, or Compact Disc Rewritable, enables multiple cycles of erasing and rewriting. One important metric associated with CD performance is read speed, commonly expressed as a multiplier, such as 52x, with 52x being the maximum read speed typical in many drives. The Digital Versatile Disc, or DVD, succeeded the CD as the dominant optical storage medium by offering a significant leap in capacity. A standard single-layer DVD holds approximately 4.7 gigabytes of data, while a dual-layer version can store up to 8.5 gigabytes. These discs became especially useful for video playback, software distribution, and storing large files. DVD formats include DVD-ROM, which is read-only, DVD-R and DVD+R, which allow users to write data once, and DVD-RW, which can be rewritten multiple times. The minus and plus symbols in the format names indicate differing recording standards developed by different industry groups, but both types are generally readable by modern DVD drives. Blu-ray disc, often abbreviated as BD, represents a newer generation of optical media designed to support high-definition video and large data storage. Blu-ray uses a blue-violet laser instead of the red laser found in CDs and DVDs, allowing for a much higher data density. A single-layer Blu-ray disc can hold 25 gigabytes, while a dual-layer version holds 50 gigabytes. Like previous formats, Blu-ray comes in writable and rewritable variants, including BDR for one-time writing and BDRE for rewriting. Because of the high data rates involved, Blu-ray discs usually require specific hardware support and, in many cases, specialized software for playback. Understanding the distinctions between Blu-ray and earlier formats is important when comparing media types on the exam. When comparing the capacities of CDs, DVDs, and Blu-ray discs, the differences are significant and should be memorized for exam purposes. CDs typically hold around 700 megabytes, DVDs start at 4.7 gigabytes for single-layer discs and reach 8.5 gigabytes with dual-layer versions. Blu-ray media starts at 25 gigabytes for single-layer discs and can extend to 50 gigabytes or more with dual-layer versions. Despite these increases in storage, the physical size of the discs remains the same across all formats at 120 millimeters in diameter. The difference in capacity is made possible by the use of different laser technologies and encoding methods, especially the shift to a blue-violet laser in Blu-ray that enables tighter data placement. To understand how optical drives function, it helps to break down the components involved. An optical drive uses a laser diode to emit a beam of light onto the spinning surface of a disc. The way the light reflects off the surface determines whether a binary 1 or 0 is being read. Inside the drive, motors rotate the disk and position the laser assembly precisely across the disk surface. Sensors detect the reflected light to interpret the data stream. Drives may come with tray loading mechanisms, where the user inserts a disk into a slide-out tray, or slot loading mechanisms, where the disk is inserted directly into a slot. These mechanisms don't affect the core technology, but may vary based on the device or system in use. Write speeds for optical media are another area that candidates must understand. These speeds are often expressed as multipliers, such as 8x or 16x, which compare the current speed to the original base speed of that media type. For example, an 8x DVD writer can write at a speed of approximately 11 megabytes per second. Read, write, and rewrite speeds are typically different, with read speeds often being the fastest and rewrite speeds being the slowest. While higher write speeds can reduce the time it takes to burn a disk, they may also increase the chance of write errors or compatibility issues with some players or drives. Therefore, selecting an appropriate write speed is a balancing act between performance and reliability. The process of writing data to a disk, known as disk burning, requires specialized authoring software. These programs allow users to select files, organize them into a disk image, and write them to optical media using compatible hardware. Most burning software includes options to finalize the disk, which prevents further writing, verify the data to ensure accuracy, or erase rewritable media before reuse. Some also support the creation of bootable media. Popular disk burning tools include Nero, a widely used commercial product, CD Burner XP, a free utility for Windows, and Disk Utility on macOS, which offers disk burning features as part of its standard toolkit. Understanding how these tools function is relevant when working with optical drives and media. One essential distinction in optical media is the difference between read-only, writable, and rewritable formats. Read-only media, labeled as ROM, are pre-written during the manufacturing process and cannot be changed. These are typically used for mass distribution, such as software installation disks. Writable formats, indicated by the letter R, allow the user to write data once. This is useful for archiving or distributing content that should not be altered. Rewritable formats, such as those ending in RW or RE, allow users to erase and re-record data multiple times, making them ideal for tasks like data backup or temporary storage. Recognizing these format types is key to understanding use cases and choosing the right media for the task. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Optical media compatibility plays a significant role in determining how different disks can be used across various types of drives. In general, optical drives are designed with a degree of backward compatibility. For example, a Blu-ray drive can typically read and play Blu-ray discs as well as DVDs and compact discs. This allows users to consolidate their media needs into a single device. On the other hand, DVD drives are limited in their capabilities and cannot read Blu-ray discs due to differences in laser technology and data encoding. Beyond hardware, software support and firmware versions can also influence compatibility, making it important to use up-to-date drivers and burning utilities when working with optical media. The interface used to connect an optical drive to a computer system is another topic that appears on the exam. Most modern internal optical drives use the serial ATA interface, also known as SATA, which offers fast data transfer rates and simplified cable management. In older systems, drives used integrated drive electronics, or IDE, also referred to as PATA, which relied on flat ribbon cables and 4-pin Molex connectors for power. Today, external optical drives are also common, especially since many newer systems lack internal drive bays. These external drives typically connect via universal serial bus ports, including USB 2.0 or USB Type-C, offering plug-and-play convenience without requiring internal installation. Although the use of optical media has declined, there are still practical use cases where it remains relevant. One key application is data archiving, where users need to store data long-term without relying on cloud services or magnetic storage. Bootable disks are also used for operating system installations, especially in situations where network booting or USB drives are unavailable. In some environments, such as schools, libraries, or legal institutions, optical disks are still used for distributing educational content or legal documents. Additionally, DVDs and Blu-rays are commonly used for playing movies and music, especially in standalone home entertainment systems. The role of optical drives in modern hardware has diminished significantly. Many laptops and even desktop systems no longer include built-in optical drives, opting instead for slimmer designs and faster solid-state storage options. The rise of USB flash drives and cloud-based storage has largely replaced the need for physical disks in everyday computing. However, optical drives are not entirely obsolete. External drives can be connected via USB for users who still require access to disk-based content. These devices provide a legacy solution for accessing archived materials, installing older software, or recovering systems using pre-burned media. Bootable optical media continue to play a role in system recovery and installation. A common method involves creating an ISO file, which is a disk image containing all the data from a physical disk. This image can be burned onto a recordable disk using authoring software. Bootable media are frequently used to install operating systems, perform system diagnostics, or recover a corrupted installation. Some computer manufacturers include recovery disk creation tools that allow users to burn their own recovery disks after setup. It is important that the system's BIOS or UEFI firmware supports booting from an optical drive and that the proper boot order is set in the system configuration menu. Proper care and handling of optical media are essential to maintain data integrity and prolong the life of the disk. Disks should always be handled by the edges or the center hole to avoid touching the data surface. Scratches, fingerprints, and dust can interfere with laser reading and cause read errors or playback issues. To prevent damage, disks should be stored in protective cases away from heat, sunlight, and magnetic fields. If a disk becomes dirty, it should be cleaned using a soft, lint-free cloth, wiping in straight lines from the center outward. Specialized cleaning solutions and tools are available, but users should avoid household cleaners that may damage the disk surface. Copy protection and region coding are two features that may limit the usability of optical media. Digital rights management, or DRM, is often embedded in commercial disks to prevent unauthorized copying or duplication. These protections may interfere with playback on certain software or hardware players, especially if the device does not support the DRM standard. Additionally, DVDs and Blu-rays are often encoded with region codes that restrict playback to devices in specific geographic areas. For example, a DVD sold in North America may not play on a player purchased in Europe. These limitations must be taken into account when choosing and using optical media in cross-region scenarios. Like any storage medium, optical disks are subject to failure. Over time, exposure to heat, light, and physical wear can degrade the disk material, leading to read errors, skipping during playback, or complete unreadability. Common symptoms of media failure include a disk not being recognized by the drive, unusually long loading times, or repeated read retries. Causes can include physical scratches, data layer degradation, or improper burning procedures. Diagnostic utilities are available that can scan disks for errors and determine their health status. When failure is detected, it is often necessary to replace the media or recover the data from a backup source. Alternatives to optical storage are now more prevalent in both consumer and enterprise environments. Flash drives offer faster read and write speeds, higher capacity, and greater durability than traditional optical media. Cloud storage services provide remote access, synchronization, and redundancy, making them an appealing option for both personal and business use. External hard drives and solid-state drives are also popular for backing up large datasets or transferring files across systems. The trend away from optical storage reflects the growing demand for convenience, speed, and reliability, with most modern workflows no longer relying on disk-based media for daily operations. To review the key points for the A+ exam, it is essential to understand the distinctions between CD, DVD, and Blu-ray media types. Each format offers unique capacities and speeds, with corresponding use cases and hardware requirements. Recognizing the interfaces used to connect optical drives, including SATA and USB, is also important. Candidates should be familiar with compatibility issues, the significance of region codes and DRM, and how to troubleshoot common problems related to optical media. Finally, understanding current use cases and the alternatives that have largely replaced optical storage will help solidify your grasp on this topic and improve your readiness for the exam. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.